Okay, I'm putting the recording back on. Okay, so the session 2, as no one has questions, session 2 focuses more on conditions and loops, and this is really where programming is, what programs are all about. Like, we can subset stuff that's kind of interesting and can be useful, but we want to be able to automate processes, and we want to be able to make a process happen hundreds of times or only happen in certain cases. And that's where programming really gets its strengths. Otherwise, you could just probably use Excel for a lot of it, right? If you're just going to do filters, then yeah, Excel can do that. And so this actually starts with a recap, but I think everyone, hopefully it's fairly fresh because we only covered it a couple hours ago. But yeah, so we have these vectors, one-dimensional arrays, matrix, 2D, factors, categories, data frames, array, but you can have different types of data inside it, and lists, anything, okay? We have the indexing, which is square brackets, and you might need a comma if you have 2 dimensions. And matrices can only contain one data type, but data frames can contain multiple. Yeah. There's recaps here mostly for like a longer form course. So I don't feel like we need to go, I'm kind of skipping through it pretty quickly. If anything's complicated, I'll call it out. We have to, factors, we have to remember about the levels, right? And levels are really important because they can limit what can be contained within the variable or the vector even. But they also help speed up processes, allow you to summarize over the data, allow you to count really quickly. And so you have to update the levels first, remember that. And then reading and writing tables. There's the read dot table and write dot table, but then there's also import, export, which you can learn from Rio. Okay. So those, if you're stuck or you like want to remember what we did this morning, there's 13 slides there that quickly give you a review of the key points. Okay. But we, like I said, we just covered that this morning, so I'm not going to hammer that to death. Like, I think it's going to be more interesting to spend time going over conditions and loops. Okay. And so I want to really drive home and encourage people to, if anything doesn't make sense, you should ask questions as soon as you see them. Because this bit can get a little confusing, especially for the first time. Okay. But I'm going to do my best. Okay, so we've looked at logical vectors, right? And we've asked the questions of like, is x less than 4? Is x equal to 4? Is y greater than 10? Things like that. And so these are really good for subsetting your data, finding out which ones you care about. But they're also really good for as logical points and controls to control whether a script is executed or not, or what procedure is used. And so kind of what we're talking about here, we have these conditionals, which will rely on these logic statements, and we have loops. Okay, so in a conditional, you're asking if something is the case, do this, else do this. Well, with a loop, you're saying for this many goes, do something, or while this is true, keep doing this. Okay, and it will cycle through and repeat. And so an example statement is like, while I'm analyzing data, if I need to execute complex statistical procedures on the data, I will use R. Else, I'll use a calculator. So you're only going to use R when you're analyzing data, and you're only going to use a calculator when you're analyzing data. Okay. If while you're analyzing data, it needs to follow, it's like complex, then you'll use R. But if it isn't, you can use a calculator. And so that's controlled by the if else. So the while is controlling what to do when you analyze data, while the if else is controlling what to do with that data. Okay. And so at this point, we get to meet the final bracket set. And so this bracket set is a little bit more complicated because it has two main things it can be used for instead of just one. But broadly, they have a similarity between them. And so when you see a curly bracket, like this one, this means use the code in between, okay? So it means execute this code. And so how it works with an if statement like we're seeing right here, you say if the statement that is in between the parentheses, so it's like an if function, if this is true, then execute this code in the curly brackets. And so the code we want to execute when x is true is a simple message, and that message says x is true. Okay, and so when you use message, it just prints something to the screen. So that's what the function is. The function is, it's nice because it just, all it does is print something to the screen. It doesn't stop anything. It doesn't save anything. It's just a message to you, the user. And so before applying this, we've made x true. Okay, so we've assigned the value of true to x. So now we say if, and so this expression here is true because it's just x. It's going to message x is true. And so we get that back, x is true from our message. So this code here is evaluated. If, however, we say we set x to be false, okay, it's going to ask, is x false or is x true? It's going to realize it's false. And so this code will not evaluate because this code only evaluates if this statement is true. Okay. So there's two key elements of the if statement, right? It's the thing that we're evaluating to see if it's true, and the outcome if it is true. So more often than not, we have a logical inside the if function here. So here we have an x and we have a y, we have a 10 and a 4. And so we're actually asking this question, if x is greater than y, then I want to do a message. Okay. So in this case, we know x is the value of 10, y is the value of 4. So x is indeed greater than y. And so this code in the curly brackets will be evaluated. And so it's saying message, the value of x is, and then we're going to have x here, which is greater than y. So this is nice because this piece of code here is dynamic and it will reflect whatever values of x and y are true. So you can update x and y and it will show them here. So when that comes out, it says the value of x is 10 because it's using the value here, which is greater than 4. Again, because we're using the variable. Okay, so now if we modify y to equal 20, x is no longer greater than y, because 10 and 20. And so the message doesn't no longer happens. Okay, because when it evaluates this, this is a false statement. And so the code is not evaluated. And so when we start to build these if statements, we want to actually get an ideal situation. If you're ever making code and you're building a function or you're building a statement like this, you always want to get a response. You always want to expect all of the, well, have an outcome for every kind of input that you could potentially have. And so you know what's going on. So to do this, we would use an else, okay? And so what an else does is it says, if this is true, let's do evaluate the first set of code. But if it isn't true, we'll evaluate the second set of code, okay? So the big way to, the key things to bring home with the structure of this is we have our if just like before. We open up the curly brackets. Right after the ending curly bracket, the closing curly bracket, we put else. And then we open up the curly bracket again directly after the else, okay? We don't need a second statement here, like this, because it's just this else is just going to evaluate if this is not true. Okay, so we've already got the conditional that else is using. It's still the same one. It's just the false version. Okay, and then you can have the second piece of code that will evaluate. So here we're assigning x to be 3 as a variable. And so we go, if x is less than 5, we know this is true. Then it's going to evaluate the first piece of code straight away. It doesn't get to else. So it's going to say message 3 is less than 5, which is what we get. That's good grammar. 3 is less than 25. I'm going to take a note of that. Okay. And then if we now modify the value of x, so now the variable of x is 10, you can say if 10 is less than 5. We know this is false. So the first chunk of code doesn't get evaluated, so none of this gets evaluated. It then moves on to the else section. And so this is false, so that means we evaluate else. And so we now have a message that says 10 is greater than or equal to 5. Okay, and that's what it prints out. And so if and else go hand in hand, they're a partnership. You can use if without else, but it's but not the other way around. So you can't use else without if. But it's always good practice if you're going to do an if statement to always have an else, just so you know what's going on. Now you can get more complicated and nuanced with this. So say, for example, you don't have a simple true or false. You don't have 2 categories you want to fit into. You want to fit several categories. You can link if and else together in perpetuity. You can just keep going if you want. So we do this by using the else if command, following an initial if. Okay, so we start off in much of the same way. This is the same. We're asking, is x greater than 5? But then when we get to the else, instead of having the open curly bracket straight away, we then have a space. And then we start another if with another conditional to evaluate. And so this, we're asking, it's stylized, but this is a double equal sign. Okay, so we got 2 equal signs. We're asking, is x equal to 5? Okay, if that's true, then it will evaluate this second chunk of code. Then we have another else, and it will, basically, if this is not true, and then this is not true, then it will evaluate this. So you can have a whole host of these if, else if, else if, else if, and it will go through each of them in turn until one of them is true, And then if none of them are true, then it will get to the bottom where you may have an else, and it will evaluate that instead. So in this case, we have a 5. It's been assigned to the variable x again. And a 5 is not greater than 5, so this is not evaluated, but it is equal to 5 here. So this is true, so we can just get this message. So message 5 is 5. Okay, so this is really nice. If else works really well with these conditional statements, but sometimes, like if you have a you want to evaluate a conditional statement over a vector, right? This will not work because you can't put in multiple values of, you can't have a vector here for x because it will get confused here. Because some of them will be true and some of them will be false. So if I put 1 to 10 here, then when it gets to this, so when it tries to evaluate is x greater than 5, some of them will be true and some of them will be false. There isn't a clear statement here for it to proceed, and it will break. So instead, you can use a function called if-else. Okay, so this is just called, this is just if-else, the function. There isn't any of this fancy structure with curly brackets. It's just a simple function. Okay, and so in the first argument of if-else, you put in your vector. Oh, no, your conditional even, sorry. And so in this, we have a x, which is 1 through 10. And your conditional is x less than or equal to 3. Okay, so that's your conditional. That would be what would go into here. And if that is true, you want this to happen. So in this case, we're just going to return a character. And if this happens, we can, Adam just asked a question. Can we use the less than equals to mean less than or equal? Yes. So the exact notation that Adam used in his question is perfect. What has happened here is so this is one of the benefits of Markdown, but also a foible with it, is this is all of our code and everything we do for the presentations is rendered using our Markdown into HTML. And what it does when it does that is it actually does some stylistic things that make it look more attractive. But in this case, it actually makes it harder to understand exactly what the code was. Because what it's done is it's converted that greater than and the equal sign into the actual greater than or equal to sign. It's the same as what happened for the double equals. So this is a double equals. So it looks nicer, but it is less intelligible. Okay. So basically with the if-else function, we have our first statement or first argument, that's the conditional. Second, it's if it's true. The third, else let's do this. Okay, and so you can see we've just got our 1 through 10. We're evaluating this. We're asking if it's less than or equal to 3. And 1, 2, and 3 are less than or equal to 3. So they get the first evaluation. And then everything else is more. Okay, so this is a much more simple nomenclature for using the function, but it's less flexible, I'd say. Because when you do it like this, you can see that you can evaluate anything in between these two brackets. You could have 30 lines of code, 100 lines of code, thousands of lines of code in your if-else statement. And that gets a lot more complicated if it's embedded within a function like this. It's harder to read. But yeah. You can also nest these in much the same way. So if you use the if-else function, you're asking x equals 3, then you call it same. Else, you execute this second if-else function, and you ask is x less than 3. And that means you can define it into, split it into the 3 groups of less, same, more, which we've done easily here for the values of 1 through 10. Okay. So that is, let me just, I want to double check the polls to see which polls we have coming up. Yeah, okay. So that is if-else, okay? So if-else are really useful conditionals which enable you to generate specific results depending on your inputs and how it interacts with this logical operation you generate. You can imagine like a common use case is if you want to categorize your data and it's, say, numerical data, you want to divide it into several groups. Say highly expressed genes, medium expressed genes, and not expressed genes, something like that. And then you can separate them based on cutoffs that you decide on. So that's what we'd commonly use these if-else's for. And so that is your logical operations. The other main category that fit with this is looping, okay? And so what a loop does is it will execute the same piece of code over and over again for a certain number of times for a for loop, or while a condition is true, okay? So while means it's going to do it so many times while something is true, or for will do it for 20 times, do this code, okay? And so we'll go into detail about how that works. So we'll start with while loops. These are, I'd say the loops and conditionals I use the least, but when I need to use them, they're the most useful pieces of code. Okay, I don't know if that makes complete sense, but I feel like there's ways to get around using for loops and things like that. There's ways to work with if and else, but there's no alternatives for a while loop most of the time. And so what you want to do is it to generally monitor how the environment is changing for whatever reason, how your data is changing, because you're modifying it in your loop, and it will wait for a certain point, and then it will cut the loop, okay? And so in this case, we're going to be asking, we're going to say x is 1, okay? And then we're going to say, while x is less than 3, I want to do this. I want to write a message, and I want to add to x, okay? So in this case, we're modifying x. And this is quite typical in a while loop. You'll be modifying something that is in the logical so that when it reassesses the logical at the start again, it will have something new to evaluate. Okay, so what it will do is it's going to ask, is 3 less than, no, it's 1 less than 3 even, which is true. It's going to send you a message saying x is 1. And then it's going to do x plus 1 is assigned to x. Okay, so that means x is now 2 because we're doing 1 plus 1. Then it will start again at the top. And so x is 2. And so it'll ask the question, is 2 less than 3? And so then it will run the code in the block because it is. X will become x plus 1. So it'll be 3. And then this will no longer be true anymore. And it will stop. And so you can see in this case, it's printing out x is 1, x is 2, and it's doing it pretty much exactly what it says. And then we can add a message at the end. Finally, x is not less than 3. Okay, so you can see how we can stitch together a while loop and a message, and then we can monitor it. Okay, so that's a while loop. And so, like I said, I don't use this that often, but when I do, it's really, there's nothing else it'll do. For loops, on the other hand, are something I use all the time. Okay, so what a for loop will do is you can cycle through some numbers, say, or a vector, and for every instance in that vector, or for every number in a sequence, I'm going to execute some code. So here we're going to cycle through a numeric vector. Okay, so we're going to give x is equal to 1 through 5. Okay, so remember we're creating a numeric vector here. And we have 1, 2, 3, 4, and 5 in it. And so then we use this very specific nomenclature. We're not using any logicals here. We're going to say for I in x. Okay. So what this means is it's going to take x, okay, and for every instance of x, which we call I, it's going to evaluate this code. So this means I then becomes used in the code as a variable which will represent the instance you're working on. So starting at the beginning, the first time it will run through, it will go with the first value in x. So x is 1 through 5, so the first one will be 1. And so that means I in this first run through will be 1. And so it will message 1. Okay, and then we have this argument for append. And so that means the message won't go onto new lines. It will stay on the same line, I think. I think that's what that one does. Okay, so then once it's done it with I equals 1, it will then do it again. It will move to the next value, which is 2. And so then I will then equal 2 in that run through. And so then it will message it again, and we get 2 out. And it'll keep doing this for all the available iterations within x. Okay, so in this case, we have 1 through 5. So it'll go through I equals 1, I equals 2, I equals 3, I equals 4, and I equals 5. And it will do them one at a time, starting at the beginning and going to the end. And so that's why we get 1, 2, 3, 4, 5. And so here we did it with numbers, but it can work with any vector. So here we're going to get letters. Okay, so there's a variable that's available to you in your environment that's just inbuilt called letters. And that will give you letters of the alphabet. And so you can use 1 through 5 to get A, B, C, D, E. You can then, if we want, we can turn it to uppercase with 2 upper. And so X will be capitalized A through E. And then we run exactly the same code. And this time it's just going to, I will then equal A, I will then equal B, I will equal C. And so with this for loop, it means you can work through any number of things and apply whatever code you want to them. As long as you have defined limits of a range of data that you want to apply it to, a start and an end, a given number of genes, a given number of plot styles, a given number of principal components, like you can use a for loop to iterate over these. And so I've been showing you how to do this to iterate over a vector. Okay, but quite often what we want to do is actually iterate over an instance. And so what I mean by that is you want to do it for, you might have multiple vectors. You might have a data frame with 100 entries. Okay, and so you can't just put the data frame into your for loop because it won't know which direction you're going in. So you can say, oh, I want to do this for the first 100 rows. And when you do that, you just give it a numeric vector of 1 to 100 with the colon. And then you can use that to index back into the data frame. So I'll show you this in action here. So we're going to have a gene name, we're going to have expression, and then we're going to use 1 to length of gene name. Okay. So this means we're going to look at 1, 2, and 3. And so you can go for I in 1 to length of gene name. That means we're going to use 1, 2, and 3 as our I iteratively. And then you can use I to index. Okay. So we can go back to our gene name vector and say, I want to look at the first entry into our gene name and message that. And then I want to go into the second, the first entry in my expression vector and grab that. And then you can message that out. And then the second time, it's going to go into the second gene name and the second expression amount. And then it will do the third. Okay. And so you can see how it prints it out. It goes through iteratively. We get this one, then we get these two, then we get these two. And so I'm hoping you can imagine, like from this dummy example, we can go back to what I was talking about with a data frame. You could have some code that calculates like the RPKM or the TPM, right? And it will, in your columns, you'll have the gene length, you have the counts per gene. And then you'll be able to go through your data frame one row at a time and do the calculation for RPKM and generate that. And then you'll go to the second one and you'll be able to, using the index of like, I'm in row 1, now I'm going to go to row 2. Using the square index, you can index out of the data frame, grab the length, you can grab the counts, and then do whichever calculation you want. And that will all be within the curly brackets. Okay. And so these simple examples will then can be extrapolated out to do much more complicated and custom code. And so one thing you can also put, quite common to put inside for loops, is actually more if-else statements. So this is where they can build off of each other, these conditionals and these different functions that we've been talking about. And so in this case, we have x is 1 through 13. And so we're going to do a for loop where I is going to be 1 through 13. So it's going to go through, evaluate it for 1, evaluate it for 2. And it's going to ask the question with if within this. So you can see there's a nesting. So this is what's evaluated by the for. It's then going to ask this. Okay, if I is greater than 10, message I is greater than 10. Else if I is equal to 10, etc., etc. Okay, and then the else, if it's not either equal or greater than, it will message it's less than 10. And so as you do the for loop across this, it will tell you number 1 is less than 10. Okay, because it's going through the value of I, which is 1 in the first case. It's going through. This is not true. This is not true. It's this one because of the else. Same with 2, etc., etc. It'll get to 10, and this will be true. So it evaluates this statement, and then 11, and 12 and 13. But this goes on too long for the slide. Okay, so you can see how it can get quite complicated quite quickly, and you can build very complex hierarchies and statements. And if you want to do something, yeah, like I keep saying complicated, but if you want to do something much more complex, you can put these together to do that. You can also use for loops in a similar way to while loops as well. So you can put in a condition that will break your for loop, so it will stop it. And so by using the if statements, if this is true, then you just write the word break. And what that does is it will stop whatever for loop is in action at that point. And so this for loop will keep running until the condition is met, which evaluates the break code. Okay. So it works in a similar way to a while, but you're allowing a lot of other stuff to happen. And then if in this very specific instance I equals 10, then we'll stop the code. Okay, so that was for loops, that was if, and that was else. Okay, and while. So for loops use a lot. And I think it's the more intuitive way of iterating over something like a data frame and doing the same thing over and over again. A better way to do it, though, 9 times out of 10, there is always the 1 time out of 10 that it's not the true, but 9 times out of 10, a better way to do it is using apply functions. Okay, so apply functions work in a similar way where you're saying, I have this range of values, this vector, this data frame, and I want to apply this function multiple times. Okay, so when I say apply this function, it's like I want to execute this code a given number of times. Okay, and so there's several flavors of apply. There's just regular apply. And what that does is it works on a 2-dimensional array, so either a matrix or a data frame. And it will return a vector, matrix, or a list, depending on the question you asked with your function. And lapply always works on a list and will return a list. And sapply is a smart apply. It applies to a vector or a list, and it returns whatever the simplest is between a vector, a matrix, or list. So if there's an option for the simplest, if all things are equal, it will give you the simplest thing. Okay. So this is applies in action. It's a function. In the first argument, you have your data. So this will be your data frame or a matrix or something like that. You'll then have your margin. Okay, and what we mean by margin is, do you want to consider this for every row, or do you want to consider it for every column? And then you finally have the function. Okay, so let's see it in action. So we have a matrix. It has the values 1 through 4. Okay, that's all this is doing, is we're making this matrix. And we can want to get the mean of the rows. So we do apply, we put the matrix in. If we want to look at rows, right, we're looking at the margin of 1. And we're doing the function mean. Okay, and so what this is going to do is it's going to look at every row, and it will give us the mean. So we have 1.5 and 3.5. Okay, And that's the value we get out. Likewise, we can switch this around. We can look at the margin of 2, which will give us look down columns. And we do apply. We have our data frame or matrix, and then we do mean. Okay, and so you get 2 or 3. So you can see, I hope that this is a nice way to start to build up functionality. And the good thing about apply is it's really quick as well. For loops can actually take a little time, but these are computationally a little more more efficient generally, depending on what you're doing. Okay, and so you can put any function here. And sometimes that function might need a few more arguments, and so you can just add those new arguments after the function. Okay, so we met paste before. Paste is used for sticking stuff together, and so what it's going to do is we're going to apply it across rows because we're using 1, right? And so it's going to take these 2 as its input and the first time, and then it will take these 2 as its input the second time. It's going to paste, and we use the argument collapse. So what collapse does is it takes everything that you've given the paste, and it will bring it all together into a single character string, and it will separate all of the things that were from different vectors with a semicolon here. But you can put anything here. And so you can see that in work here. So it's going row per row. We get everything from the row, and we're getting it separated by the semicolon. If the matrix was bigger, right, it was coming out here, it would just get all the values in the row, 1, 2, 5, 6, whatever. And it would all be separated by the semicolon because that's what we're collapsing by. So that's apply. That's one of the ones you'll probably use the most because it works specifically on data frames, okay? And that's most of the time you're going to be getting this nice rectangular data. It's going to be genes on one side, and you're going to have some properties associated with those genes, and you're going to be want to infer all kinds of things like what is the mean in my groups, or what is the standard deviation, or you want to perform an operation like I was talking before, and you want to transform some of the data based on several of the properties. So maybe you want to apply by row a custom function to calculate RPKM. You can do that with apply. Lapply, on the other hand, okay, it applies a function to every element of a vector or a list, okay? So, and it will return the list. So in this case, we are doing a very, very complex operation here. We have a vector, which is a 1 and a 2, okay? We've combined them with the C, and we're asking what their mean is. And so we're asking the mean of one number, right? Because it's going to do the 1, and then it's going to do the 2. It does them separately. And so we're asking the mean, so we're just going to get a 1 and a 2 back. What we can do, well, it can cope with more complicated things like this. And so here we have a list as the input. And we have, in the list, we have one slot, which is just a single 1. We have a second slot, which is a vector, a character vector, and it has an NA in it. And then we have a third slot, which is a 2. And we're going to add just an additional argument at the end. We want to remove NAs, just like we did for the paste example. Okay, we had collapse afterwards. Okay, so this is an argument that's being supplied to the mean. Okay, so that's the thing to remember with all these apply statements. You'll have your first couple of arguments, which are always consistent, which is the data object you care about. And the function, if you're doing a regular reply, you'll also have in between, you'll have the dimension you care about or the margin. And then after that, it will just be arguments that I'll be giving to the actual function that you're using. Okay, so, but we're using na.remove, which means we're going to apply mean to all of these, and it's going to ignore the na. If you do not have na.remove and you ran this, it will error out because it has no instructions for what to do with the na. So last but not least, we have sapply. So sapply pretty much is the same as lapply, except it will try and reduce the results to something more sensible. So like here, we have these 1 and 2, 1, 1, 2. Like these are very simple outputs, but they're contained within lists. It's quite complicated for very simple outputs. So what it would do in that case is it would simplify it down to a vector. Yeah, and so where you might always get a list with lapply, you'd actually get something much better to handle with sapply. And so you can see this in action here. We have our list, and we have a vector, and we're just doing means on them. Okay, and in both cases, we get a vector back. If we did exactly the same thing with lapply, you'd get a list of vectors. Okay. So this is actually a more complicated one. So we'll go into it in detail. So we're using the function called Quantile. So what Quantile does is it breaks up your vector into different quantiles. So in this case, we have 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And what lapply is doing is it's going to go into each element in your list and say, what are the quantiles for this? Okay. And because we just have 5 elements, it's just going to break it into 5 quantiles. And yeah, so this is equal to the 0%, this is equal to the 25%, this is equal to 50%, etc. While in row 2, this is equal to the 0%, while this is equal to 100%. So this is like useful, but it's like not the best comparison between. It's hard to interpret what's happening with row 1 versus row 2 versus row 3. If you did exactly the same with sapply, it simplifies it down into a matrix, and they're all right next to each other. So it makes it easier to compare and to do further analysis on this. So sapply is super useful. Okay. sapply does its best in all cases, but if it can't make a matrix or a vector, it will make a list. So again, this is we're creating a data frame. Oh, we're creating a list. The list has a data frame in it. Okay, df equals data frame. But it also has a vector. Okay. And so you have a data frame and a vector, they're very different. And so if you apply a function to them, they're going to do very different things. And so we're going to apply the function summary to them, and the result of the summary is shown here. Okay. And that's because the objects produced from summary of a data frame and summary of a vector are very different. And so they can't be just coerced into a matrix. They can't be coerced into a vector because they're different shapes and sizes. And so what it will do is it will just make a list in this case. Okay, so it's still performing the operation, but it just has some flexibility built into it where it knows what the data is and it will change its output depending on what the data looks like. Okay. So there's a lot of information. It's the more complicated parts of what we are doing today. I'm going to throw up a poll to see how everyone's doing with conditions, loops, and apply. It's also a good time to just take 5 minutes, have a break. And then we've got one last section, which is going to be about custom functions. So I'm going to throw this up for a minute. If anyone has any questions, we can go through some of the stuff, or if you just need to go stretch your legs because it's been a long day, do that, and we'll get going for the last bits at 4. Oh, you can only select one? Okay, let me see if I can update that. Sorry. That's why, yeah. Okay. Okay, so I can't update it on the fly, I'm afraid. I clicked the wrong button for single answer versus multiple choice. But I think most of you found the most obvious one. How about we do this? I'm going to share the results. It is a bit of a mixture, and we've only got a few people. So, but what we can do is if everyone, I'll ask the question, if else loops through data. Who thinks that's true or false? If you write a T or an F in the chat, we'll do that. Cool. Yeah, I think most people get this. It is false. So if else doesn't like loop through your data, it will just consider what it will consider a single operation. Okay, and that will be a single logical operation. You can put it inside a loop so that it will loop through your data and then consider that operation multiple times, once for each loop through. Or you can use the if-else function, and then that will assess that over an entire vector, but it won't be looping through it or do it in a vectorized way. Okay, so I think most of you got the next one, but it's while is a loop and a conditional. Let's do true or false in the chat. Yeah. Yeah, I think most of you get that. Yeah, so you have a conditional statement that controls the loop. So it's truly the hybrid between the two. And so these are the contentious ones. We have basically the same statement. One says apply uses a function against all rows of a data frame, while the other one says sapply does this. So maybe write apply or sapply, depending on which one you think does it. Okay. So we've had a few responses, and we've had Javier coming in at the last minute with the right answer. So we've had one person get it right. So if we remember, apply is specific to data frames or to matrices, and it has the extra variable margin. Okay. So let me just show you that. So that means you can control whether it does it over all rows or all columns. Okay. sapply doesn't consider this. It doesn't have a consideration for a row. It doesn't have a consideration for a column. It accepts either a list or a vector. And so you can use it on a data frame, but you have to actually use the index for the data frame. So let me show you that real quick. I can, where's my RStudio? Okay, so I have a matrix, and it's 1 to 10, and it's a 2 by 5. Looks like this, right? Oh, I have it. Let's use this guy up here, named matrix. Okay. So this is what my matrix looks like. Now, if I want to do apply, and I want to do mean over all of the rows, or across the row, it looks like that, right? And if I want to do it across the columns, it'll look like that. But if I do sapply, so sapply doesn't have an argument for a function. It considers every single element in the matrix individually. But what I could do is something more complicated. And then and we create our own custom function. Okay, and so this is what we're actually going to do now. But I thought I'd give you a quick taste. Is yeah. Oh, I did that wrong. Sorry, I'm coding on the fly, and this can go badly. Oh, I do. Yeah, that I can see why. And then we need to actually put the named matrix in this. So if you give me 2 ticks, I'll just explain what I'm doing. Yeah, okay. So what I've done is the same as this here. And so what I've done here is, I'm going to put it up here so I can break it apart a little bit. I'm saying to sapply, I want to look at the vector 1 to 2. Okay. And I'm going to use this custom function that I'm just writing here. So this is the code for a custom function. Okay. And in this custom function, I'm going to use the value of x Okay, so this is my argument for my function, which is going to come from my sapply. And what I want to do in this is I want to go to my matrix. I want to get the x row, and I want to find the mean of it. And so the first time it goes through, it's going to find the first row. The second time it goes through, it's going to find the second row. So this is something relatively common to do if you do not have the right function or you don't have a function that will do exactly what you want to do. Maybe you can customize it a little bit, or you can start to build your own code to make a custom function. And from there, be able to run it in apply. And that is exactly what I'm going to show you how to do for the last part of today's session. Okay, so hopefully this makes sense with what I just showed you. And so I was creating a custom function on the fly, but here I'll show you how to create a function that you actually assign into your environment, and then it's in your environment and saved there. Okay, so we're going to create this function called myFirstFunction. You need to use the function, and this just lets R know that you're defining a function. Then you put in the parentheses any arguments that the function would have. Okay, so for mean, this would just be some numbers, right? But say for what is it? So some of the functions we've been using that I've already forgotten is like dir, right? dir. The first one would be path, right? So you'd put in an argument that's path. Then maybe you need more arguments, so you can just comma separate them. Then you open up the curly brackets. Okay, so this is the other time that you see curly brackets. And so really it still means this is a section of code that I want to execute in a given situation. So in this situation, it's when my function is called. In previous situations, it's during my for loop, or if this statement is met, or something like that. Okay. And so your code to execute is then contained within here. And then what value you want to return is put into the return function. Okay, so you'll do some computation here. You'll create something that's your result, and then you'll put your result in the return. And so that means the function knows this is what I'm delivering. And then you close it off with a curly bracket. And then all of this gets assigned to whatever you want to call your function. And so then I can call my first function. You put in your parentheses, and then you can put in my argument equals whatever the user will use. Okay, so that's all the theory. That's the layout. Let's actually show it in use. So here we're going to create a function which just adds two numbers together. Okay, really straightforward. And so to do that, you need two arguments, number 1 and number 2. And then the code needs to actually add them together. And then you need to return the added together numbers. Okay, so you can see that here. So we have function, we have the arguments that we're expecting, two numbers. We have the code we want to evaluate. So that's contained in the curly bracket. We have the actual code we want to execute. So that's number 1 plus number 2. And we're going to save this as some num. Okay, and then we're going to return this because this is the output we want to get from the function. As sum, we return some num. Okay, so this function, once you evaluate this code, is now a function available in your environment to use. So you can then run this function. So you say my first function, and you can say num1 equals 2 and num2 equals 3. So this means these are your inputs. They will be evaluated by this code, and you can get your result when you run this, and it's a 5. Okay. Now, as you create your functions, you'll probably want them to be able to do more and more complicated things. And an important caveat to note is that return will only return a single thing, okay? And so in this case, we are both summing the numbers and multiplying the numbers together. So you can see we are using the asterisk for multiple. And when we execute this, we get an error. Multiple arguments in returns are not permitted. So what you need to do is, if you have multiple results, is you need to group them together. And so this is where knowing lists can become useful. Or in this case, we can actually just use a vector because they're very similar data types. But I can imagine there'll be an instance where you might need to use a list and you can return a list. But here, what we're doing is we're getting our sum num, we're getting our multiple num, and then we're combining them together and we're creating a vector of results. We're adding names to our vector of results. So we're adding multiple and sum, and then we return it. Okay, and so then we run when we run this again, we can get the multiple and we can get the sum. Although these are named back to front. To make it extra confusing. But our first one should be sum, the second one should be multiple. Right, we all know that 2 plus 3 is 5 and 2 times 3 is 6. Okay. And so as I was mentioning, lists can be very useful here because if you want to make a data frame, but you also are returning a vector or something like that, then it becomes quite challenging to vectorize that in a different kind of data type. So here, what we're doing is we have the same thing, but we actually want to return the input into the data object. So you have a record of the input in the function. But what we also did was we turned this one into a data frame. And so now you have a vector and a data frame. And so a good way to return both a vector and a data frame at the same time is you put them in a list. So we turn them into a list, and we have our input values, and we have our results. And then you just return the list. And so now you have a list with our input values, and we have our result. So a lot of what we've been focusing on is how return works, because it's a key. Most of the other stuff is fairly straightforward, but return has some nuance to it. One of the other factors to remember is with return, it is the end of your function. Okay, so if you ever create a function and you want to return something, but you want it to keep doing something else after that, that second chunk of code will not evaluate. And most of the time, you won't be structuring anything like this, but sometimes you might put a message in and you forget to put the message before the return. Okay, because quite often you want to say, you have a message that says, oh, we successfully did this, or report some of the values saying my standard deviation was this, and it reports it straight to the screen. But if you put that message after the return, it won't do anything. Okay, so you can see that here we have the same function we just ran before. And when we evaluate it here, you can get the before return message, but this message for after return never gets evaluated. So return is similar to a break almost. It just calls the end of the function. And so there are ways to get away without using a return. It's always good practice to have a return because it's a very clear statement of like, this is what I expect. If someone else or you later on are reading your code, it makes it a lot clearer if it's delineated what you're exactly expecting from this. But if you do not specify it will return whatever the last line in the function is. So if, for example, you put in what you were going to put in your return statement as your last line of code, it will still work in exactly the same way. It's just good coding practice to delineate exactly what you're hoping for. Okay, so this is the only thing that's really changing here. It's just not putting a return. Something important to know with how functions work is that when you're inside a function, it's like a separate environment. The scope of those variables are limited to that function, okay? And they typically only don't have as much access to the other variables, okay? So if you create something, like here we create some num, okay? You run it. So some num existed at some point because you ran it and you got a result of 5. However, when you look for it in your environment, it's not there. And that's because it's created in a very transient way while the function is there. While it's there, it's accessible, but it's only accessible to the function. And so you can still access the global, depending on, 99% of the time when you're running these functions, it can still access all the global environments that are there. So for example, here we have a third number. We're defining it outside of the function, but we're using it inside the function. Okay. I would say that, though, that often that's not the best practice. You generally want all the variables to be defined in the argument set, and you can add defaults and things like that. But this means that if you ever use the function, quite often you're copying and pasting functions between different analysis sets, and you want it to have all of the things that it needs with it. And so if you wanted to I wanted to actually use this function somewhere else, it's quite easy to not pick up this line of code. And then you've got to figure out what your third number was when you translate it to somewhere else. Similarly, when you update, similar to this, right? You're creating some num and it's not available to you. If you update a global environment within a function, that update is not reflected in your global environment. So here we have my third number, which is 4. And we're actually adding num1 and num2 to it. And so they sum up to 9 in total. And that would be my third number is being assigned to that. We're returning it. And when you look at your result, you get 9. But when you look at my third number, it's still its original value of 4. So this still gets down to this limited interactivity between inside your function and outside the function and the variables there. There are ways to get around it. And you can do that with this. So you use the double assignment. So you use 2 less than sign. However, this is generally considered bad practice. Okay, it's much better to export whatever you want to export by having it come back as a return statement and then assigning it afterwards. Quite often with these functions, if you start doing this, things might get rogue, and then you might forget that it's doing this, and then you can overwrite environmental variables very quickly that are important. It's one of those cases where more control and more finesse is needed by being more explicit later on. Okay, but this does work, and there are cases when you might need to do it. Okay. And so some other nuances with your creating your own functions is quite often you'll want default values. And we've seen some of these before, right? When we talked about data frame, it has strings as factors equals false these days. And it's really easy to add these when you define your function. So all you have to do is just, when you define the argument, you just put an equals to and whatever you want the default to be. And so that means if I then run this, my first function, without any arguments now, it will still work. It will work on 1 and it will work on 3. But I can still then use it with new values, and it will ignore the defaults. Okay, you can see the difference here. Here, it still functions because it has some default values to fall back on. But here, it has some actual arguments to use. So it'll use these values that you've given it. And so these can be as long as complicated as you want. Okay, so in this case, I have a function that is going to calculate a z-score. And so that will be based on one number and a vector of numbers. Okay, so you can supply that one number and the vector. Okay, so we're calculating the z-score from our distribution in A based on the first position of A versus the distribution of all of A. And so in this, it's calculating the mean, it's writing a message, it's doing a subtraction, it's doing some standard deviation, and then it's doing a division. And all it's returning is that final z-score, okay? And so we get a message, and then we get this z-score, which we can save. And so this is also, I say that this is complicated. This is very simple. Some functions that we build are hundreds of lines of code, and they do incredibly complex operations. But then you can run them much like this, my z-score, and it will just do it all for you. And so these things you can build up over time. As you start to build your own functions, RStudio has some nice utilities to help you with this. I'm not going to demo them because it's getting late, but as you start to build these functions, they're quite intuitive. There's debug and undebug. Okay, well, debug, you write debug, you use your function, try it out, and it will go through step by step. And if anything breaks, it will tell you where it's breaking. It allows you to work much more interactively with your function and to understand what is not working. And then when you want it to stop doing that, you use undebug, okay? And then these custom functions can also be used with apply. So just like the custom script I showed you right at the beginning of this, where I was calculating the mean using sapply, here I'm applying my z-score function to all of A using sapply. Okay, and so then it calculated the z-score for all of this distribution A. Okay, so I think when we did we have a couple more things, and then I'll give you one last poll, and then we'll be done. We pretty much covered loading libraries when we talked about Rio, but just to go over it again explicitly, there are a ton of libraries. You can install them. If you need to figure out like a good resource is for biological ones is you go to Bioconductor and you can look at the packages available there. And then you do install.packages to get them in. And then you can load them in with library. If you ever want to see what packages are available, you can use library with no arguments, and it will tell you what arguments, what packages you have installed. And so we showed you how to install them before with install.packages. This is the hmisc package, but you can also install them through RStudio as well using tools install packages. Okay, so you can do it in a GUI way. Okay, and so these packages really open up a whole world of potential possibilities. And you can use they often have what's called a vignette and a website, and you can go to them and they'll have guidelines for how to use the packages. especially for bioconductor packages that have things to help you with bioinformatics, they'll have often entire workflows that help you step by step to work through analysis. Okay, I have a quick question. So in the sapply example, what was the third argument for? Okay, so I assume Nathaniel's talking about this. Okay, and so in my z-score, it has two arguments. It has a number argument and it requires a vector. Okay, so for those of you who aren't familiar with z-scores, what a z-score is it's calculating the mean deviance or how much deviation you are from the mean. Okay, and so if you have a distribution of data, lots of points here, I'm using just a normal getting a normal distribution of data, 20 data points. Okay, that's what our norm function does. So A is just 20 data points that follow like a bell curve, essentially. And what this is doing is it's comparing a single data point versus all of them and saying, how far am I away from the mean, essentially? What is my mean deviation from the mean? And so for this, we need both the distribution of data, of all the data, and the actual single data point. Okay? And so if we now go to our example, yeah. So this is just the second argument in the function. Okay? So the A is being passed through the apply. So it's going to go through all of A one by one. But A is also the vector it's being compared against. Yeah, it's not the best design function or intuitive, but hey. Yeah, so expanding your R library is really kind of straightforward. And it's just about doing install.packages and then library to load them into your environment so you're ready to go. The other way that you can really start to like turbocharge your what work you can do is by saving scripts. And we're going to go into R Markdown and making reports and things like that. But what you can do is save scripts that contain functions and then load them in very easily. And we'll show you how to do that. So if you have an R script and it has a function, so say the function I just wrote recently, or any function you might write, you can save it in a R script. So that's a .r. And then when you do source, okay, so here we do source and we source this script. This script is now available to use in your environment. Okay, so I could have a library of R functions which I use on a regular basis, and then I can just source them in if they're all in the same R script, and then they'll all be accessible to me. So this is a nice way of, if you're creating functions that you're going to use on a regular basis, this is a nice way to start to organize these functions together. So you don't have to worry as much about writing them out each time. You can have a centralized place where you're like, oh, I have a very specific way I like to draw MA plots, and it's very custom. I'm going to write all the code for it. I'm going to turn it into a function. And then whenever I'm going to do some RNA-seq analysis and do an MA plot, I can source it in and then use it. Okay. And so this is exactly what's inside here. Here, this day of the week script isn't available in my environment, but what it does is it tells you what day of the week it is. Okay. And so this code was executed last Tuesday. So that's why it comes back as a Tuesday. You can also, you don't have to work with R interactively through RStudio if you want to be able to walk away. And And specifically, if you want to use R in the HPC, quite often you'll find that maybe you'll run an R script without opening up an R session. And so to do that, you use the command R script, and then you tell it where your R script is that you want it to run, and it will just run it. Okay, and so this is just a quick idea that you can do this. This will be all through terminal. And so it is using R to execute an R script, but it's without opening up an R session interactively. So this is all possible. This is how you start to get to the more advanced stuff like you do on the HPC. And this is what it would look like. But obviously, you need to get a better handle of the basics before you can start to grab onto stuff like this. Yeah. And so if you're going to do this, the big caveat with doing this is you have to make, and you want to pass arguments. The big caveat is you have to make the arguments available to read. And so you just have to chuck this at the front of your script, and then it will read in arguments from the command line. Okay, so these extra little bits about scripts here at the end are little tidbits just to give you an inkling of where you can go with this. I do think, especially early days, this sourcing of scripts as you start to build your own functions is super useful. If you can build just have a script file where you can put together functions that you use for analysis more commonly than not. And going beyond this, if you need help, we're obviously going to be seeing each other over the next few days. So you can bring back, like tomorrow is going to be a relatively lighter day because we're just going to be talking about plotting most of the day. So if you have questions about today's sessions and you want to talk about them tomorrow, that is totally fine. But you can also go to our GitHub, raise that issue that I showed you this morning. You can also email us, but we prefer it to go through the issues because then it's a public place that if people have the same questions. Google places forums like Stack Overflow and OurHelp are also incredibly important resources. The most important skill that I've learned is how to Google things properly. That will be your friend and will be the most important skill that you will learn if you get into bioinformatics.